Hi, in this question we are asked to solve a differential equation which also have an initial condition which is given as y of 0 is equal to 1. So first of all we have to solve the equation and form a general equation. After that we have to find the constant c in the equation. That's how we approach this question. So we just write the function dy by dx is equal to 4x plus y plus 1 the whole square, right? Whole square, right? Okay, we start to solve this equation by assuming like t is equal to, let us assume t is equal to 4x plus y plus 1. So it is mean to be like we have to continue with our to be in variable separable form. For that we assume t is equal to 4x plus y plus 1. So what will be dt by dx? What will be dt by dx? Dt by dx will be 4 plus dy dx plus 0. Okay, right? So from this we can write dy by dx will be dt by dx minus 4. Okay, now we got a substitute for dy by dx in terms of t. Now what will we do is we just substitute this in our main equation, this equation. So dy by dx, instead of dy dx I can write dt by dx minus 4 is equal to, instead of 4x plus y plus 1 whole square, I can write what? We assume t is equal to 4x plus y plus 1. So we can just write t square. So it can be written like dt by dx is equal to t square plus 4. Now we have to change this function into a variable separable form. So how it will be? Dt by t square plus 4 is equal to dx. Now it is in a good perfect variable separable form. What's next? The next step, we integrate this function both sides. So dt by t square plus 4 equal to integral dx, which means in the left hand side what will be? We have a general term like integral of 1 by a square plus x is equal to 1 by a tan inverse x by a. So like that, how it will be? Integral of dt by t square plus 4 will be 1 by 2 tan inverse t by 2, okay, equal to integral dx, which means x plus c. We have a constant c. So this is the general equation, but we can't stop here because we are already given with an initial condition. So uh, before that we also have to resubstitute our t, right? We have now the general equation in terms of t, so we can just rearrange all this stuff. So how can be tan inverse t by 2 equal to 2x plus c. Now taking tan, we have to neglect avoid this tan inverse. So for that I like it will be like t by 2 is equal to tan of 2x plus c. This 2 will be given here, then what will be 2 tan of 2x plus c. T is equal to 2 tan of 2x plus c. What is t? T will be 4x plus y plus 1. So it is given that in the initial condition it is given that y of 0 is equal to 1. So here what we do, we substitute x with 0, and what will be the function value of y. So when we substitute this, we will get like c is equal to pi by 8. So we got c is equal to pi by 8. Then how will we proceed? We just substitute pi by 8. Now what you have to do, we have to just substitute this c in our general equation. So what will be our equation? Our equation will be 2 tan of 2x plus pi by 8 equal to 4x plus y plus 1. So we can distribute this 2 into bracket, then 2x plus pi by 4 is equal to 4x plus y plus 1. Okay, so this is our solution for the differential equation here. So if you have any doubt in substituting for c, you should ask me. And in this step what you have done is we just substituted x is equal to 0 and y equal to 1. If you have want to elaborate it, I will describe here it once more. It is like we have, it's given like y of 0 is equal to 1, which means we have to substitute y equal to 1 and x is equal to 0, because this is the parameter x is the parameter here and parameter x is 0 here. So and its result is 1, so y equal to 1. So we just substituted that thing in here. We only have the unknown c, so solve for c. So 2 tan of 2 into x is 0 plus c, okay, equal to x is 0, then y equal to 1 plus 1 2. So 2 is equal to 2 tan of 2c is equal to 2. Okay, then tan inverse 1 equal to 2c, then c will be pi by 8, because tan inverse 1 is pi by 4, then 2c is equal to pi by 4, then c is equal to pi by 8, like that. Okay, so that's how we got c is equal to pi by 8. Okay, now we have finished with this equation. We got the general solution now, and we got the exact solution because we substituted with c with the real value using our initial conditions.